Okay, so today we're looking at question 160, intersection of two linked lists. Given the head of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. So here we're given an example. List A and list B, they intersect at node C1, so we're supposed to return C1. And they wrote that there are no cycles anywhere in the entire linked structure, and we have to note that the linked lists must return their original structure after the function returns. So here's a little bit more information on how they judge your what you return. So yep, I'll skip past this part in the interest of time, but I will link this question in the description box below. Example 1, we can see that linked list A is shorter and linked list B is longer, but they both intersect at node 8, so we're supposed to return this node. And example 2, it's the other way around. List B is shorter and they intersect at node 2, so we return this node. Finally, we have an example where they don't intersect, so in this case we return null. And here are some constraints. Number of nodes of list A is denoted by m, number of nodes of list B is denoted by n. M and n can range between 0 to 3 times 10 to the power 4, and the node values can range from 1 to 10 to the power 5. Skip A and skip B, which are their inputs, the custom judge's inputs, can range from 0 to m for skip A, ranges from 0 to n for skip B. If there are no intersection, intersect val is 0, and if there is an intersection, intersect val is equal to list A skip A and list B skip B. So here's a follow-up, which is like a hint for us that we can have a solution that runs linear time and only uses constant memory. Okay, so I think because it's possible that it's possible that there's no nodes in a linked list, either list A or list B, that's that possibility. What we can do is kind of get rid of that condition, and in the sense that we directly return none if we find that it's an empty linked list. So we can do something like if not A or return. Okay, so once that's out of the way, we can start drawing for the cases, for some cases where let's say the lists are of different lengths. So let's get our drawing mode, get into the drawing mode, and let's just use example 1 for our illustrations. So we have A and we have B, right? So A is, maybe we should draw B first because it's longer, right? 5, 6, 1. Oh, let's redraw that. And then goes to 8, 4, 5. for 1 goes to 8. Okay, so the trick to solving this question is basically, first of all, we have to figure out like what's the difference in length of these two linked lists. So we kind of have to think of a way to get like our pointers pointing to these nodes, basically at the point in time where the nodes that we're pointing at, like we only have to take an equal number of steps before we reach the common node, which is in this case node 8. So once we somehow get our pointers to this node 4 of list A and the first node of list A and the second node 6 of list B, we just have to like increment both pointers like one step, and step 2 we get to this node value, and then we can directly return this, right? So how we can do that is basically figure out what's the length of B. Figure out what's the length of both lists. So let's, in this case, we have A as 1, 2, 3, 4, 5 nodes, and B has one more, right? So 6. 1, 2, 3, 4, 5, 6. So we kind of like move B's pointer like by 1. So as you can see over here, like it's now in this position, so that we can make sure that they will step together to the common node. So this will work for like all different kind of cases. Let's give it another example. Say, maybe let's clear this diagram. Say example 2, right? Example 2 is we have A, B, something like that. My drawing's horrible. Okay, so we can see that list B has 3 nodes. List A has 5. So the difference is 2. So we somehow have to go like 1. Let's use a different color. 1, 2, and then it stops here. Okay, it's like, okay, I'm ready. And then like B starts at the head. Like we start at the head of the shorter linked list, and then we start walking them like one step, and they both reach this node. Then we return. Yep, that's about it for the explanation part. So let us start implementing. Okay, so I want to write like a function to kind of like get the length, just because we have to get length of list A and length of list B, so I don't really want to like repeat that. So let's do something like length, get length, and we pass in list, my list maybe. Oh, I think we're missing the self. Okay, so we need a variable. So return length zero. We start off as 0. So while my list. Return length. And maybe we should rename this return length. Length of list, length list. Yeah, maybe something like that. Yeah, okay, so if we pass in a list, it will keep traversing until like the end of list and keep incrementing our length list counter. So let's see. So we can do something like length LA, just okay, maybe like spell it out. Self dot get length head A, length B, head B. Okay, so we have length A and length B now. Okay, what's next? Now that we have the length, let's compare it, right? If length A is more than length B, so length list A is the longer list, then we step the longer list, like the number of like steps that's the difference of the lengths A and B. So for I in range, length A is longer, right? So length A minus length B. Length B, length A. Else contains both the situations where length B, list B is longer, or list A and B are the same length. So for okay, so we're done stepping. We are now at the stage where our oh no, what have I done? Okay, I should have assigned, okay, so length A are integer pointers, like they're just integer values, right? So I should have assigned pointers first and instead stepped the pointers instead of doing like length A dot next and length B dot next, because that would definitely result in an error. So let's do that. Pointer A, head A, pointer B, head B. Okay, so okay, so like we said, we're gonna be at the position where yeah, the blue arrow's pointing at. And now we can start incrementing both pointers together. While pointer A not equals to pointer B, pointer A finally we return like either one. Let's just return pointer A. So what this while loop is doing is basically like walk both pointers together. But in the case where there are no intersections, eventually they will reach, not eventually, if in the case where there's no intersections, they will actually reach the point where they are both null values. So that's when it will exit the while loop. And at that point in time, it doesn't matter if we return pointer A or pointer B. They should be either the intersecting node or a none. Okay. Okay, great. So that's it for today's video. Thank you for watching.